Hello students, welcome to lesson 7 on angle of elevation and depression. I hope you are all doing well. Good. In our previous lesson, we looked at example 6. We solved the question on example 6 and then I gave you an assignment. I hope you've all done the assignment. Good. Now in this lesson, we'll look at example 7, which is a little bit involving than example 6. But before we begin, let's first look at the solution to the assignment. Right, so this was the question. Now I'm going to read the question and then we'll proceed by looking at the diagram and the solution. Okay, good. So let's read. The angle of elevation of the top of a lighthouse from a boat at a point A is 30 degrees. When the boat sailed 40 meters towards the lighthouse to a point B, the angle of elevation of the top of the lighthouse increased by 20 degrees. Find I, the height of the lighthouse to two decimal places, II, the distance between point B and the foot of the lighthouse to the nearest meter. Good. So now we've read the question. Now let's proceed by looking at the diagram. Good. So this is the diagram. Now CD, okay, CD is what? Is the lighthouse. Okay, then A is the boat. So we're told that the angle of elevation of the top of the lighthouse from the point A is what? 30 degrees. So that is how come we have 30 degrees here. Now we're also told that when the boat moved from point A to point B, that is 40 meters towards the lighthouse, okay, the angle of elevation increased by what? By 20 degrees. So initially the angle of elevation was what? 30 degrees. So when it increases by 20 degrees, it means that we are going to what? Add 20 to what? To the 30 degrees. So that we'll get what? 50 degrees. Okay, so that is how come we see 50 degrees here at what? At point B. Okay. Good. So the angle of elevation of the top of the lighthouse from point B is what? 50 degrees. I hope you are okay. Good. So now, to make our work simpler, we are using H to represent the what? The height of what? Of the lighthouse. And then we are using X to represent the distance between point B and what? The foot of the lighthouse. Okay? Good. So now looking at the diagram, you realize that there are two right angle triangles, the smaller one and the bigger one. So the smaller right angle triangle is BCD, okay, and the bigger right angle triangle is what? ACD. I hope you are clear. Good. So here we are going to find the height of the lighthouse based on the smaller right angle triangle, and then the height of the lighthouse based on what? The bigger right angle triangle. So let's proceed. So from triangle BCD, okay, that is the smaller one, tan 50 degrees is going to give us H on X. So making H the subject, we are going to get X tan 50 degrees, okay. So with the help of the calculator, tan 50 degrees will be giving us 1.1918. So substituting and multiplying, we are going to get H to be what? 1.1918x. Okay, so this is the height of the lighthouse based on what? The smaller right angle triangle. Good. So now let's proceed to look at the height of the lighthouse based on the bigger one. Good. So from triangle ACD, that is the bigger right angle triangle, tan 30 degrees is going to give us H on what? 40 plus X. So making H the subject, we are going to get 40 plus X into bracket tan 30 degrees. So expanding, we are going to get this. With the help of the calculator, the tan 30 degrees will be given as 0.5774. So substituting, this is what we are going to have. And then simplifying, we are going to get this. So H will be equal to 23.096 plus 0.5774x. So this is the height of the lighthouse based on what? The bigger right angle triangle. I hope you are following. Good. So now we are having two heights here. The one based on the bigger right angle triangle and then the one based on what? The smaller right angle triangle. But they are all the same, okay? So here there are two ways. Either we make x the subject and we substitute it in the second equation, or we just replace this h with this, okay? So it will be simpler for us to replace this height by 1.1918x. Okay, it will be simpler and easier that way than making x the subject and substituting it. So that is what we did. So now, substituting 1.1918x in place of the second h, we are going to have 1.198x equals this, okay? Then grouping like terms, we are going to have this, okay? Good. So now we are to make x the subject. So let's proceed. So x is going to be 23.096 on 0.6144. So with the help of the calculator, we are going to get the x to be what? 37.5911 meters. Good. But we are looking for the height first, not what? X. Okay. And we know that the height was equal to what? 1.1918x. So now that we have x, we can substitute x here, and then we solve for what? H. So substituting and multiplying, our h will be equal to what? 44.8011 meters. But we're told to leave our answer to 2 decimal places. So now the height of the lighthouse will be equal to what? 44.80 meters. Okay, so we conclude by saying, therefore, the height of the lighthouse is 44.80 meters. Good. So students, this is the answer to the I. Okay, this is the answer to the I. Now let's look at the II. Let's look at the II. Now the II, we're to look for the distance between B and the foot of what? Of the lighthouse. The distance between B and the foot of the lighthouse. And that is what? BC. Okay. So that distance is what? BC. And we know BC is the same as what? X. Let's check it. Okay, so BC is what? The same as X. So we have calculated for what? X already to be what? 37.5991 meters. So BC is equal to it. And we're told to leave the answer to the nearest meter. So 37.5991 meters to the nearest meter is going to give us 38 meters. 38 meters. So we conclude by saying that the distance between B and the foot of the lighthouse is 38 meters. 38 meters. So students, this is the solution to the assignment. Now, take your time and go through and check if everything is on point with yours. If everything is correct with yours, then you've done well. Clap for yourselves. If we're also not able to get all of it, okay, take your time, check your corrections, and then make sure you don't repeat it the next time, okay? Right. So now that is for the assignment. Now let's move on to our major business for the day, which is example 7. Right. So this is example 7. This is example 7. So as we've been doing all this while, we have to read the question to understand, visualize it, and then we draw a diagram using lines. To be able to draw the diagram, we have to use the definition of angle of elevation to help us identify the point of observation and the object. Okay, good. So we are going to follow the same procedure to answer this question. Right. So now let's read the question. Sorry. A flagstaff 10 meters high is on top of a tower. From a point X on the ground, the angles of elevation of the top and bottom of the flagstaff are 60 degrees and 30 degrees respectively. Find I, the distance between point X and the foot of the tower. II, the height of the tower to the nearest meter. So now we have read the question. Let's read it for the second time to enhance our understanding. A flagstaff 10 meters high is on top of a tower. From a point X on the ground, the angles of elevation of the top and bottom of the flagstaff are 60 degrees and 30 degrees respectively. Find I, the distance between point X and the foot of the tower. II, the height of the tower to the nearest meter. Good. So we have read the question, we have understood it. Okay? We've read the question, we have understood it. It's now left for us to draw a diagram. Okay? But before we draw the diagram, let's take note of the key things we need from the question to help us draw what? The diagram. So we're told that a flagstaff is what? 10 meters high. So we need a flagstaff which is what? 10 meters high. And it's on top of what? Of a tower. So it means that we need what? A tower. Okay? From a point X. Good. So it means that point X is what? Our what? Point of observation. Our point of observation is what? Point X. On the what? On the ground. So X is on the ground. The angles of elevation. Good. Of the top and bottom. Good. So here it means that we are having two objects. The top and bottom of what? Of the flagstaff. The top and bottom of the flagstaff. So we have one point of observation and two objects. Are 60 degrees and 30 degrees respectively. So now you know the respectively means what? In that order. So the angle of elevation of the top comes first. So that one will be what? 60 degrees. And that of the bottom will be what? 30 degrees. Good. So students, these are the information we need from the question to draw the diagram. So now let's proceed to draw the diagram. Good. So we have a tower. So this is our tower. And there is what? A flagstaff which is 10 meters high on top of what? The tower. So this is the flagstaff and it is what? 10 meters. Now we're also told that there is a point what? X, which is what? On the ground. Okay? I hope you are following. Good. And we're told that the angles of elevation of the top. So the angle of elevation of the top of the flagstaff is what? 60 degrees. So this is the angle of elevation of the top of the flagstaff, 60 degrees. And the bottom, so the bottom too was giving us what? 30 degrees. So that is it. As we said, one point of what? Observation, two objects, the top and bottom of what? Of the flagstaff. Okay, good. So this is the diagram. Now let's complete the labeling. So this be X, Y, Z, and W. Good. So student, this is the diagram. So now, don't forget to always bring your 90-degree angle sign here. Okay, this is 90 degrees. Good. So to make our work simpler, let's use H, okay, to represent the height of the tower. And then let's label the distance between point X and the foot of the tower, X. Good. Right. I hope you are following. Good. Now you realize that we have two right angle triangles put together here in the diagram. We have the smaller one and the bigger one. The smaller one is triangle XYZ. Okay, that's the smaller right angle triangle. And with that one, the angle is what? 30 degrees. And then we have the bigger right angle triangle, which is what? XYW. With that one also, the angle is what? 60 degrees. Okay, I hope you are following. Good. So two right angle triangles put together. Now here, what we are going to do is that we are going to first of all find the height of the tower based on what? The smaller right angle triangle. And then we'll find the height of the tower based on what? The bigger right angle triangle. Okay, so that is what we are going to do. We are going to find the height of the tower based on the smaller right angle triangle, and then the height of the tower based on what? The bigger right angle triangle. So let's proceed quickly. Good, let's proceed quickly. So from, that is the smaller right angle triangle. So from triangle X, Y, Z, okay, from triangle X, Y, Z, the trig ratio connecting H, X, and 30 is what? Tan. So we are going to have tan 30 degrees to be equal to what? H on what? X. So making H the subject, we are going to have X tan what? Tan 30 degrees. Okay, so with the help of the calculator, our H is going to give us what? Let's find tan 30 from the calculator. Good. So tan 30. Okay, tan 30 is giving us what? So we have 0.577. So to 4 decimal place will be what? 4. 0.5774. So we are going to have X into bracket 0.5774. So our H is going to give us 0.5774x. Okay, 0.5774x. Good. I hope you are following. Good. So this is the height of the tower based on what? The smaller right angle triangle. Now we have to look for the height of the tower based on what? The bigger right angle triangle. Good. So from triangle X, Y, W, that is the bigger right angle triangle. Now tan 60 degrees, so there the angle is 60, will be equal to, so the opposite is what? The 10 plus what? The H. Okay, so 10 plus H on what? On the X. Okay, so let's check it. So the opposite is what? The 10 plus the 8. The adjacent is what? The X. Good. So making H the subject, we are going to have X tan 60 degrees to be equal to what? 10 plus what? Plus H. So we are to send the 10 to the other side to make what? H the subject. So we are going to have X tan 60 degrees minus 10 to be equal to what? H. So our H will be equal to, so let's use the calculator to find what? Tan 60 degrees. Right. So now tan 60, okay, is going to give us what? 1.7321. 1.7321. Good. So we are going to have 1.7321x minus 10. Okay, 1.7321x minus 10. Good. So this is also the height of the tower based on what? The bigger right angle triangle. Okay, good. So now we have two heights here. The one based on the smaller right angle triangle and what? The one based on what? The bigger right angle triangle. Okay, good. So let me write the one based on what? The smaller right angle triangle also here. So that is 0.5774x. Good. Now, to make our work simpler, okay, we can first of all find the distance, that is the value of x, and then we use it to find what? The h. Okay, or you can make x the subject and substitute it in this one to find what? The h. But it will be easier for us to find the x first and then use the x to find what? Find h. Okay, so here looking at it, this is h, this is also h. So it means that in place of this h, we can put what? 0.5774x what? There. I hope you are following. Good. So we are going to substitute h with what? 0.5774x. So let's proceed. So 0.5774x, okay, will be equal to 1.7321x minus what? 10. Minus 10. So here we have to group like terms. So 10 will be equal to 1.7321x, okay, minus 0.5774x. I hope you are following. Good. So now let's find 1.7321 minus or 0.5774. 1.7321. So minus 0.5774. Okay, so let's see what we get. We are getting 1.1547. 1.1547. So our 10 is going to give us 1.1547x. Good. So making x the subject, we are going to have 10 on 1.1547. 1.1547. Good. So we have to go back to the calculator again. Good. So with our calculator, we want to find 10 on, so 10 on 1.1547. 10 on 1.1547. So let's see what we are getting. We are going to get what? 8.660. So here it will be 3. 8.6603. 8.6603. Good. So let's do it here. So our x is going to be 8.6603 meters. 8.6603 meters. Okay? 8.6603 meters. Good. So that is x. That is x. That is x. Good. So the x is what? The distance between what? Between x and what? And the foot of what? Of the car. X is the distance between x and the what? And the foot of what? Of the car. I hope you are with me. Good. X is the distance between x and the foot of the tar. Right. So we're not told to leave it to specific what? Decimal place or specific approximation. So we can leave it here. Okay. We can leave our answer at this point without approximating it. Okay. Good. So let's conclude. So therefore the distance between x and the foot of the tar is 8.6603 meters. Therefore, the distance between x and the foot of the tar is 8.6603 meters. Good. So that is what? The I. Now let's look at the II, which is what? The height of what? The tar. The height of the tar. The height of the tar. The height of the tar. Now remember that h is equal to what? 0.5774x. 0.5774x. So now we have x. Okay. So from our h being equal to 0.5774x, we have calculated for x to be what? 8.6603. So our h will be equal to 0.5774 into bracket 8.6603. Okay, good. So now multiplying, let's get our calculator to do the multiplication. So we are multiplying 0.5774, okay, by 8.6603. 8.6603. So let's see what we are getting. So we are getting 5.005. 5.00. So 5.0005. So we have 5.0005 meters. But we're told to leave our answer to the nearest meter. We are told to leave our answer to the nearest meter. So we conclude, okay, by saying, therefore, the height of the tower is, so it's going to be 5 meters. So therefore, the height of the tower is 5 meters. Good. So students, this is the solution to example 7. This is the solution to example 7. And this is where we'll end for today. This is where we'll end for today. So take your time, go through the video again, and you'll be fine. Okay? Right. So, you know I will not leave you without an assignment. Right. So let's look at the assignment. Good. So this is the assignment. A very beautiful question. Okay? A very beautiful question. Right. So take your time and then you'll be able to solve it. Okay? Good. So, till we meet again, revise, read ahead. Bye.